Hello Year 12 and welcome to our next video here on correlation and regression. We're looking at lines of best fit. Now you've probably seen these before in some way, but we use this line of best fit when we've got a scatter plot, when we see that there is a fairly obvious linear correlation, and we draw a straight line to try to best represent that data. Now unless it is a perfect correlation and those points all form a neat straight line, I can't put a straight line that perfectly represents the data, but we do the best we can, thus the line of best fit. Now there are a couple of sort of guidelines, a couple of things that we aim for when we're doing this, to try to represent as many of the points as closely as possible, to go through as many of the points as possible. That's a good thing, because you represent them exactly then. To have roughly the same number of points above and below the line, and the sum of the distances above and below the line to be roughly equal. Okay, but it is a certain amount of judgment when you do this, so your line of best fit may be a little different to mine. Now once we've got that line there, then we could work out the equation of it. Yep, gradient y-intercept is what we're going to need, and from there we could also use that equation, or even the graph of the line, to try to predict other scores that might fit in that data set. Now if I choose scores that are within other values within the data set, right, so if it's in the middle, it's called interpolation, and that's fairly reliable generally. If we are looking for a point that is outside or external to the data set, then we call that extrapolation, right? It's generally less reliable. Anyway, we need to plot the points from this data set that we've looked at before. We need to plot this in another scatter plot. I'm going to pause the video here for a moment while I do that. Year 12, check out this graph here. Now it's far from perfect. I haven't drawn it with pencil and a ruler, as you should. Now, a couple of things to point out. As before, when we look at our data, we have the height in the top row and the arm span underneath it, which implies that the height is the independent variable, and that belongs on the horizontal axis generally. And that's why the height goes across here, the arm span's going up. We've put our points there. It would be nice in this case, well, it's nice in some cases, to be able to bring the axes back to the origin of 0, 0. Particularly then it allows us to read off the y-intercept by drawing that graph. But in this case, in this particular case, where our data is grouped around the sort of 180s, 200 sort of area, that's an awful lot of extrapolation to try to get to back to the y-intercept. So it's not and you know, we just have this tiny little cluster of data up in the top right hand corner. So it's not really reasonable in this case here. Now I've got my axes labelled. Oops, that should be 200, not 20. And that looks sort of okay. I've put my my points along here, and I've drawn a line of best fit through the middle. It's not perfect, but we can see we've got sort of 2 points above and 1 point below, and the rest are very close. And I've got the two above are fairly close. The one below is sort of is further. So the sum of those distances, by and large, that's not a bad line of best fit. A bit of an estimate. Now from here, so I'm quite happy with that. There's my my line of best fit. But to find the equation of this line, right, what I'm best to do is to choose 2 points, ideally fairly far apart, but also ones that you can read nicely, that represent this data fairly well. So I'm going to use these 2 points here, right, because they seem to fall smack bang on the line. I need to find the gradient and the y-intercept. So I have this one here, which is 192, 194, and oops, right, I've got those ones over here, and my other one here would seem to be, that's at 197, 200. Okay, those points seem to well represent this data. So from here I need to find the gradient. The gradient is the rise over the run. Okay, so it's how far up I go. That's 1, 2, 3, 4, 5, 6. over the run of 1, 2, 3, 4, 5. So I think the gradient as 6 over 5 or 1.2, I think that seems fairly reasonable. Let's just check that again. 1, 2, 3, 4, 5. Rise of 6 over a run of 1, 2, 3, 4, 5. Rightio, that's my rise over run. Now my y-intercept is a bit trickier. I'm not going to extend this down till I get to the axis because it is, well, that tiny little cluster of dots up in the top right hand corner. It's going to be hard to draw a line of best fit accurately through what's going to, by the necessity of scale, be a very small cluster. So what I'm going to do is this. I'm going to say y equals mx plus b, we know that, and I'm just going to choose, I think I'm going to choose these numbers here, okay? So I'm going to say, remember this is x and this is y, so I'm going to say, instead of y equals mx plus b, I'm going to say 200 equals 6 over 5 times 197 plus b. Now a little bit of algebra is going to tell us that b equals, what does it equal? 200 minus 6 by 197 over 5 equals, and I'm going to need my calculator here. Tell me if, oh, I don't have my calculator, hang on. I found the calculator. Now let's type this in. 200 minus 6 by 197. Oops. Oh, that's going to work, okay. 6 by 197 over 5. Right, 6 up the top or 6 at the front, that's right. Equals, let's change that to a decimal. Negative 36.4. Now this tells me that, I'm going to say that y equals, 6 over 5 is 1.2x minus 36.4. That is my equation of the line, that's b here. So let's just go over that. How did we do it? We looked at our line of best fit in our graph. We found two reliable points, ideally data points, but they could just be like nice points like this, right, that you can see the graph is going through, that you can read off neatly. So I think we might just check this one, right? This is 185 and what have we got? 186. So what happens if, now I've got two calculators, here we go. Let's do 1.2 times 185 equals minus 36.4 equals 185.6. Not too bad. That would suggest that probably it should be more like down here, which goes to show that that you can't draw these things and read them perfectly, right? But it's a reasonable sort of estimate. Now, when you draw this, if you chose different points, you may very well get different values there, but you should get a similar sort of a result. So I'm going to say here y equals 1.2x minus 36.4. Okay. Now, use the graph in the equation to estimate the arm span of a male swimmer, 191 tall. Height, 191, so we're going to go up here. Do we hit the line? And then across. And my graph tells me that should be about 193 centimetres. 193 centimetres. What about my equation? Let's try the same thing. 1.2, we've got this equation. 1.2 times, what do we say, 191 minus 36.4 equals, back to the calculator, okay, 1.2 times 191 equals minus 36.4 equals, here we go, 192.8, about 193. Pretty close, okay, that's pretty good. Now we're going to use the graph and the equation to estimate the arm span of a male swimmer with an arm span of 195. Right, okay, well, my arm span of 195, remember, arm span here, Go across till we hit the line and drop down, and I think we're just inside that one here. So I reckon we're about 192. Let's say 192.5. 2.5. We'll make a little estimate there. It's somewhere in the middle. Centimeters. My equation. We are going to say that 195 equals 1.2x minus 36.4. So that means that 195 plus 36.4 equals 1.2x. Means that x is 195 plus 36.4 divided by 1.2. Back to the calculator. 195 plus 36.4 equals, divided by 1.2 equals 192.8. 192.5. That looks pretty good to me. Rightio. That is a line of best fit. So if you've got a scatter plot, draw the line to best represent the data. Try to go through as many dots as you can, right? As close to many as you can, about the same number above and below. Right? Now, from that, we can interpolate or extrapolate, whether that's interior or exterior of the data, I guess. And we can generate the equation of the line of best fit by reading off, right, a couple of points on the line and finding the gradient and the y-intercept. Righto, that's all for this video. It's quite long enough. If you've got any questions, I'll see you in class.